All right, welcome back to part 3. Hopefully this will be the last part. So we just got done finding the normality. Normality condition has been met. Next we need to do independence. All right. So in independence, the population should be at least 10 times as large as the sample. Now you have to do both samples. So we are fairly safe to assume that at least 6,500 people take acetaminophen and at least 3,470 take ibuprofen. Okay, so we took the sample size 650 times 10 and we got the 6,500. And we took the 347 times the 10 and got 3,470. You have to check both of them. Okay, now we can go ahead and do the math. Now don't forget, we already put the numbers into the calculator. So all we need to do is go to our calculator. Again, all of our information is in this screen, pretty much everything that we need. And then when you want to draw the normal curve, you can go back and do the draw option. All right, so again, pull all the information from this screen and backload it onto your paper. All right, so here we go. So first of all, p hat sub 1, again, the calculator gave that to us. That's 0.0677. Here's p hat sub 2. All right, so p hat sub 1 minus p hat sub 2. Okay, now for the denominator. So filling that in, don't forget, for this part, we used p hat combined times 1 minus p hat combined, so multiplying to the complement there, times 1 over the sample size of the first one, which is 650, plus 1 over the sample size of the second one. So again, all we did was pull that from the calculator, plug them in. Okay, and then we get our z-score right here, negative 3.082. Okay, the calculator also gave you the p-value. Now you'll notice that from the picture, we have 1e negative 4. Don't forget what that means. That simply means move the decimal 4 places to the left, so the p-value is 0.00014. Obviously, that is very, very small. So it is significant. The p-value, with a p-value as small as 0.00014, there is strong evidence to reject the hypothesis and conclude that the two pain relievers differ in the proportion of people who experience an adverse reaction. Now, we can only say differ because that's what our alternative was. We don't know if it was worse or if it was better. Now, when we do number 5, when we do the confidence interval, we will actually be able to see something more concrete about whether it was a good thing or a bad thing. All right, so let's go ahead and do this confidence interval. We're going to construct and interpret a 90% confidence interval for the size of the differences. Now, remember, normality condition is not the same as the test statistic. So you actually have to go through, you already did the other conditions, but you have to go ahead and you have to do the correct normality condition for the confidence interval. Now remember, for the confidence interval, we do not combine the proportions. Okay, we take the first sample times the proportion for that sample. So that would be the 650 times the 0.0677. And that gives us 44. And then its complement. And then the same thing with the other one. The second sample times its proportion. Okay, look at them carefully, think through it. Okay, now, the conditions are all greater than, I didn't put that part down, but the condition is met. All are greater than or equal to 5, so things are good. All right. Okay, now, again, we have this information on our calculator. So let's go to Stat, Test. Okay, let's make sure we pick the appropriate one now. We're doing an interval. Okay, so number 6 again is a 2 proportion z test. Number 7 is a z interval, but that's not the right one because we're dealing with a proportion. Number 8 is a t interval. No. Okay, number 9 is a 2 sample z interval. Okay, no. 0 is a 2 sample t interval. No. A is a 1 proportion z interval. No. B, at least on my calculator, is 2 proportion z interval. Yes. So we're going to use B for this one. Again, I've already put all of the data in. I just need to make sure my confidence level is correct. So going back to the problem, I want a 90% confidence level. So I just need to go down here again, change that to 0.90, and calculate. All right, so again, it's given you p hat 1, which we already knew, p hat 2, gives us n1, n2, and this is what we want right at the top. It says negative 0.1083 and negative 0.0388. All right, so let's go back. I got my numbers plugged in. Again, look at it carefully. This is p hat 1 minus p hat 2. This is our z star for 90%. Okay, this is our p hat 1 times its complement over 650 plus p hat 2 times its complement divided by 347. And we got this interval. Okay. Yes. So, what is our conclusion? Okay, now, we don't want to put negative percents in our answer. So let's think about this. There's 2 ways you could write this. We are 90% confident that between 3.9% and 10.8% fewer people suffer adverse symptoms from acetaminophen than ibuprofen. Or we are 90% confident that between 3.9% and 10.8% more people suffer adverse symptoms from ibuprofen than acetaminophen. So either way you could write it, you just got to watch how you do. Okay, the fewer people, okay, the acetaminophen, there were fewer people that had adverse effects than ibuprofen. If you switch it around, more people, okay, had adverse symptoms to ibuprofen than to acetaminophen. Okay, if you think about it, go back up here, okay, it kind of makes sense because 44 out of 650 had adverse symptoms, where 49 out of 347 had adverse symptoms for ibuprofen. So, I mean, if you think about it, you could kind of figure that out because the sample size for the acetaminophen is quite a bit larger with fewer adverse symptoms than the sample size for ibuprofen and the adverse symptoms there. Okay, I am going to have to go to a part 4 to do the last example. So see you in part 4.